Okay, in this video I'll be going over the review for test 1, and it's possible this may turn into, I'm guessing, 2 videos. So let's go ahead and get started. So on problem 1 we've got these graphs to do, and I would always encourage you to try them first and then you can check your answers by watching the video. So let's see how you did on A. To find intercepts, you want to make an XY chart, and let's let x be 0, and so we'll find the y-intercept when we do that. So you can plug in 0 for x, and when we solve this, notice negative 3 times 0 is 0, and 0 plus 4y is 4y. So we're going to get 4y is equal to negative 12, which means that y is negative 3. So when we choose x to be 0, we get y as negative 3. All right, let's look at B. Or I'm sorry, let's find our x-intercept. So this time we're letting y be 0. Now similarly, you can plug 0 in for y, and if you put a 0 in for y here, oops, let me change colors. So a 0 in for y here, this part zeroes out, and you're left with negative 3x equals negative 12, which means x is 4. And so that is your x-intercept. We can plot those on the xy axis and draw the line, and we're done. Excuse me. So that's how we find the graph using the intercepts. And notice this is in what we call standard form. And in a case like this, often it's the case that the intercepts are a good way to graph these. All right, so on B, we have this equation in slope-intercept form. That's this form. And we can use the slope and the y-intercept to do the graph here. So first of all, the slope is negative 3/2. Our y-intercept is the point 0,4, so we're going to go to 4 on the y-axis. And we're going to go, our rise is negative 3, so we'll go down 3. Our run is 2, so we'll go right 2. And then draw your line, and you're done. X equals 3. Well, you're going to go to where x is equal to 3 and draw a line that's vertical. Notice that every point, hold on just a second, every point on this graph has an x value of 3. Y equals negative 4, we're going to go down 4 on the y-axis, and you would draw the horizontal line, and so that's y equals negative 4. X equals a number is always a vertical line. We know those have an undefined slope. Y equals a number, we're going to get a horizontal line, and that's got a slope of 0. Now, if you have problems and you find yourself forgetting which way to go, vertical or horizontal, one thing you can do for like x equals 3 is just pick 3 points where x is 3 and pick y to be whatever you want. I usually choose 0, 1, and 2. These 3 points are on this line that we found. Similarly, you can do the same with y equals negative 4. And you'll find that those points are indeed on this line. So that's a good way to make sure you have it right. All right, let's look at slide 2. So you should be able to determine whether these are functions or not. Again, I would encourage you to look at them first and then watch the video. All right, so the first one there is a function. Each input has exactly one output. If you look at the second one, you'll notice that negative 3 is an input that has 2 different outputs, 4 and 2. In fact, if I called this the f function, we would be able to say that f of negative 3 is 4 and f of negative 3 is 2. Remember again, with a function, each input, or x value, has exactly one output. Here you have an input with 2 different outputs, and so this is definitely not a function. For the graphs below, we can use the vertical line test. So on the first one here, you can clearly see that there's a lot of places where if we draw a vertical line, we go through more than one point. And so that is not a function. And then the other two, though, if you look at those, no matter where you draw vertical lines, you cannot go through more than one point. And so these do pass the vertical line test, and these graphs do represent functions. All right, let's look at problem number 3. So you should be able to look at a function like this and determine where you're increasing, decreasing, or constant. These are going to be intervals of x values. You're basically starting out here on the left, and you keep going to the right, and then you continue on, and you're reading the graph from left to right over x intervals and describing what's happening. Is the function increasing, decreasing, or constant? So again, you can see on the left, this graph's going down. From left to right, it's going up, so it's increasing. Actually, let me put these labels in. So it's increasing from negative infinity until you get to right here, where x is equal to -7. Remember, this graph continues forever left and forever down, but the key is it's going forever left. So from negative infinity, when x goes from negative infinity until you get to -7, this graph is increasing. So now, in this little stretch, it's decreasing. So that's when x goes from -7 to -5. So we'll put that there. And then now from -5 until you get to -2, you're constant. So -5 to 2, we're constant. And now you can see we're going to increase between -2 and 1, -1. And so we would put a comma and then put the interval -2 to -1. And then notice from now on the graph is constant, so we're constant on the interval from -1 to infinity. All right, let's move on to number 4. So it says determine the domain of each function. So this is one that you should be able to do pretty quickly. If you look at A, that's a linear function, and so we know the domain is all real numbers. Every linear equation has a domain of all real numbers. The graph of this function looks, well, I'm a little steep, something like this. And you can see it goes forever left and forever right, and it certainly has a domain of all real numbers. As you plug in inputs, you can plug in any real number, multiply it by 3 and subtract 7, and you'll get another real number. So there are no problems plugging in any value of x, and so we have a domain of all real numbers. On B, we know that this is quadratic. If you were to graph it, it has a graph that looks something like that. Again, you can see that it goes forever left and forever right, and so the domain here is also all real numbers. In fact, it's going to be the same for all of these. On letter C, this is a absolute value function that's going to be V-shaped, and this one actually is going to go down, but it doesn't matter if it goes up or down. Whoops. It's going to go forever left and forever right. The domain's going to be all real numbers. And finally, this last one here, remember y equals x cubed is what I call the John Travolta graph. This graph looks something like this. Whoops. It's kind of got an S type of shape. It does continue off to the right. This does go forever left. And so keep in mind, it doesn't just go straight down. It is going to the left. It is going to the right. And so this -2 in here is just causing us to go right 2, a horizontal shift right 2. And the 1 causes this graph that I just did to also go up 1. So basically, if you shift this graph right 2 and up 1, you still have a domain of all real numbers. That is our domain. And I just want to remind you that there's only 2 types of functions that we've studied so far, written in equation form. that have a domain that's not all real numbers. Fractions, where you have an x in the denominator, and square root or radical functions, or in particular square root functions. So let's move on to the next slide. And so now you're going to find the domain of these. So again, I would encourage you to try them first and then watch my video solution. All right, so on A, first of all, you should recognize that if x is 4, the denominator would be 0 and we would be undefined. And so x equals 4 is not a value that we can plug into the function. So in other words, x equals 4 is not part of the domain. Our domain will be everything else. Negative infinity to 4, union 4 to infinity. So in this function, what we're saying is your input can be any number but 4. Because if you plug in 4, you end up with a denominator of 0, which makes you undefined. Now, I want to point out something here. First of all, sometimes students will say x can't be 0. Well, if you plug in 0 into this function, you'll end up with negative 4 in the denominator, and that's not a problem. The other thing is sometimes students, well, the other thing about x equals 0, notice that makes the numerator be 0. But we don't care about that. 0 divided by any number, that's 0. So the numerator can be 0, that's no problem. The only issue we have, the only thing that's going to cause us to have a restriction in the domain is any x value that makes our denominator 0. And so it's just 4 here. All right, on B, you're going to need to factor the denominator. This is a trinomial, and there's several ways to factor this, but for one of the ways is, you know that x times x is going to give you x squared. You know you're expecting to get two binomials here. Then you look at the 30 here. You're looking for two numbers that multiply to negative 30 and add to negative 1, that middle term or coefficient. Two numbers that multiply to negative 30 and add to negative 1. That's going to be a negative 6 and a positive 5. And so I'm just going to replace x squared minus x minus 30 with its factored form. So now you can see that in the denominator, x can't be 6 or negative 5. Those are the values that would cause your denominator to be 0. So that's where the function would be undefined. So our domain is everything else. So negative infinity to negative 5. Then we're going to go from negative 5 to 6, and then 6 to infinity. So all this is saying here is our domain is all real numbers except negative 5 and 6. Those are the values. If you plug them into this function, they make the denominator 0, and so you're undefined. For that reason, they're not part of the domain. All right, in C, it is a fraction, but notice the denominator will always be 3. It can never be 0. And so for that reason, this is all real numbers. There are no restrictions. So be careful. Just because you see a fraction, it doesn't necessarily mean that your domain has a restriction. All right, on D, we have a radical. And we know that if our radicand, what's under the radical, if it's a negative number, then we're taking the square root of a negative, which is an imaginary number. When we're doing graphs or working with functions, everything's got to be real numbers. I always say you got to keep it real. And so what we want to do is we want our radicand, 2x minus 3, to be greater or equal to 0. Because I can take the square root of 0, and I can take the square root of anything that's positive that's greater than 0. So I need 2x minus 3 to either be 0 or greater than 0. When we solve this equation, we get 2x is greater or equal to 3, which means x is greater or equal to 3 halves. In interval notation, we go from negative 3 halves to infinity. And by the way, if you were to plug in 3 halves, you would find out that you'd be taking the square root of 0, which we know is 0, no problem. If you choose something greater than 3 halves, you'll be taking the square root of a positive number. And so these are the numbers that you can choose for x, values that you can plug in as an input for x, and your output will be a real number. All right, let's move on to number 6. All right, so here you have a piecewise function. So there's 3 pieces. The first one is basically the graph of y equals negative 3x minus 18, but it's just the piece of that line when x is less than negative 5. And then between negative 5 and 1, you're using the function y equals 2. And finally, if x is greater or equal to 1, you're using y equal, or f of x equal, x plus 2. Remember, y is another name for f of x. So again, these 3 graphs, we can take pieces of them and put them together, and we call this a piecewise function. So now for finding f of negative 5, notice that we're in here when x is between negative 5 and 1. Notice the equal sign here. That means we're including negative 5. We're going to use the second piece here, y equals 2. That just means no matter what your input is, your output is going to be 2. Now notice 0 is also between negative 5 and 1. So again, we'll have an output of 2. What about f of 3? Well, notice now x, our input, is greater or equal to 1, and 3 is greater than 1. So we're going to take our input, x, our 3, and add 2. And so we get 5. All right, let's move to the next slide. So here it says, draw a sketch of the graph, then determine any relative minima or maxima. All right, well, let's see, on the first one here, the parent function would basically be y equals x squared. Y equals x squared. This half that's in front is going to cause a vertical, actually it is a vertical shrink. The graph ends up looking more flat. So vertical shrink, vertical shrink. And this minus 4 is going to cause us to go down 4. So we're going to go down 4, and we're going to draw the same graph, but it's going to be a little more wide looking. And so there's the graph of this function, just a rough sketch actually. Notice the only point that's exact is the vertex. But we have more than enough to find the minima, or minimum value here, because it's the bottom of a valley, the lowest point. Whoops, oh, I wrote that in the same place. Let me go back here, and I will erase this. And let's do it now. So we have a minimum value of negative 4 when x equals 0. So in other words, no matter what input you plug into this graph, you plug into this function, it doesn't matter what it is. The smallest your output's ever going to be is negative 4. All right, if you look at b, the parent function is y equals the absolute value of x. And so the minus here causes a reflection through the x-axis. This minus 2 inside with the x in the absolute value is going to cause us to go right 2. And the 3 out here is going to cause a vertical shift up 3. So normally what we do is we do the reflection first. So that would reflect it down through the x-axis. Again, we're reflecting through the x-axis. And then we're going to take that graph and we're going to move it 2 to the right and 3 up. So it's going to be right here. It's going to look just like my light blue graph, but it's going to be at, the vertex will be at 2, 3. And so it's going to look like this. So now notice here you're going to have a maximum value. You're going to have a maximum value of 3, and that occurs when x equals 2. So again, no matter what you plug in as an input into this function, you're never going to get a larger output than 3. All right, let me ask you another question while we're here. What if I said find the domain and range for each of these? Now on the first one, you can see Notice we're looking at the purple graph there. It goes forever left and forever right, so the domain is all real numbers. Now with range, remember you go from the lowest point to the highest point. And we do have a lowest point, and the y value there is -4. But this graph does go up forever, and so there is no highest point, and so we say our range would go from -4 to infinity. If you look at the y values on all the points on this graph, they're going to be as low as -4, but there is no highest y value if you look at all the points. On the next one, the domain is still all real numbers because it goes forever left and forever right. Again, we're looking at this graph here. The range, notice this graph has no lowest point, and so we start in negative infinity land. And then at the highest point, the y value is 3, so our range is -infinity to 3. All right, so here you ought to be able to evaluate a function if I give you some input. So for f of -1, if you plug in -1, well, first of all, I made a shell or a skeleton. When you plug in -1, now you want to use the order of operations to simplify the right side. The first thing you're going to want to do is square the -1. Well, -1 times -1 is 1. Times 2, you're going to get 2 times 1 plus 5. We end up with 8. So I have two A's here. This should be B. On the second one here, set up a skeleton or a shell. And this time you're replacing your x's with a plus 2's. So this one's going to take a little bit of algebra to get simplified. The first thing we're going to need to do is square the a plus 2. So let's do that down below. When you FOIL this out, you end up with a squared plus 4a plus 4. So we end up with 2 times a squared plus 4a plus 4. Next we're going to distribute a negative. We'll get a minus a and a minus 2. Don't forget to bring down the plus 5. And then the next step, you're going to distribute that 2. Combine your like terms. Notice there's one a squared term. We have an 8a and a minus 1a. That's 7a. And notice we have three constants. 8 minus 2 is 6. Plus 5, you get 11. All right, I'm going to go ahead and stop this first video here.